I'm really sorry I have to do it, but it must be done. We must talk about this summation notation. It's not pretty. It's a pain in the ass. But we'll get through it together. Trust me. So, let's say we want to write 1 plus 2 plus 3, plus 100. The notation for this in mathematics would be this. We have the stylized sigma, which is a sum. We have I goes from 1 to 100, meaning I is going to hit every integer between 1 and 100. And this is what we're going to plug in. So we have 1 and a 2 and a 3. That gives me all this stuff. A shorter example, let's say I want to say the summation as I goes from 2 to 5. I can start wherever I want. I can end wherever I want. We kind of want to end after we start, because otherwise time goes backwards. It's just kind of weird. So I need to let I equal 2, and then 3, and then 4, and then 5. So we plug that in. We get something like this. I have a 2, I plugged a 2 in, a 3 in, a 4 in, a 5 in. Crank out, that's just arithmetic. I get a 46. Now, we have some theorems that will help us. First off, if we have a sum of two different expressions, both with i's in them, or we have two things here, we can break them up and sum up just the first chunk and then sum up just the second chunk. So let's go back to that example we just had. So if I have the summation as I goes from 2 to 5 of 3i plus 1, I can rewrite that as the summation from 2 to 5 of 3i plus the summation from 2 to 5 of 1. And then crank it out that way. It doesn't look much better, but it's just rearranged a little bit. Unfortunately, we get the same answer. Another thing you can do is if there's a constant inside the summation that has absolutely nothing to do with I, you can suck it out. You are factoring it out. Just like if you had 2x plus 4, you can pull the 2 out. We're doing the same thing here, but this is just a more generalized summation. So let's go back to my 3i plus 1 example. I can pull the 3 out of this expression, so now I'm adding up i's from 2 to 5 and 1's from 2 to 5. Again, maybe not so helpful yet, but it will be. I have the summation as I goes from 1 to 15 of I squared plus 2i minus 5. Okay, I can split this up. Let's split this up as I can add up the I squares. I can add up the 2i's, but the 2 gets sucked out. I can add up the 5's, but the 5 gets, or the negative 5 gets sucked out. Okay. I don't have much formulas here. This one, if I'm adding up 1 15 times, that's just going to be 15. That won't be too bad. These I'm just going to have to crank out. Gross. At least you didn't have to type all that. So I have square everything from 1 to 15, add everything from 1 to 15, and then 5 times 15 for the last term. Crank it out. I won't make you sit through that. And I got 1405. There should be some theorems. There should be some formulas. We should be able to simplify this so it's not so crazy. And there is. We already noticed this one. Notice that if I add up 1, go from 1 to n of 1, I'm adding up 1 plus 1 plus 1 plus 1 n times. I'm going to get n. Okay, so this is our first formula. Let's go to adding up the i's. 1 plus 2 plus 3, n minus 2, n minus 1 plus n. Let's play with this for a while. Notice that if you take the first and the last term, you get n plus 1. If you add, look at the next to last, if you look at this one and that one, you get n plus 1. If you look at this one, all the way into the middle, you're going to get n plus 1. So let's see if we can make this a theorem. If n is even, that means there's a halfway point. That means I can say n divided by 2 and still have an integer. So that means if I'm adding 1 through n, someplace in the middle I'll hit n over 2. And then the next one is n over 2 plus 1, on up to the end. Notice that this half and that half both have n over 2 terms. And I know that when I pair them off, each pair is n plus 1. So this is n plus 1, the next one's n plus 1, all the way out. So I have n plus 2 pairings of n plus 1. So the sum is n over 2 times n plus 1, which is equal to n times n plus 1 over 2. Cool, we have a formula. Let's look at the odd one. I have to do both possibilities. Oh, look at that. That's not supposed to be there. Ignore it. Suppose n is odd. Well, then n minus 1 over 2 is an integer. Because if n is odd, n minus 1 is even. That's an integer. This one here, n minus 1 over 2 plus 1, is the dead center, because you know if you've got an odd number, here's 5 fingers, the middle one, you will have a middle number with even things on both sides. Pairing these up on either side of the middle term, I have n plus 1. Over on this side, this first chunk, there are n minus 1 over 2 numbers over here. See, minus 1 over 2. I have the same number over there. So if I'm going to add all this stuff up, I have n minus 1 over 2 times n plus 1, because that's all the pairs I have along the side. And then I have to add the middle term in. So there's all that, and there's the middle term. Now if I do some algebra manipulation, that simplifies to n times n plus 1 over 2. So whether n is odd or even, we will get this formula. So the summation as I goes from 1 to n of I is n times n plus 1 over 2. Yay. So we have 4 formulas, 2 theorems, 2 formulas. We're going to need a couple more. I'm not going to prove them for you right here. I'll try to make another video because I'm sure you're dying to know why the other formulas are what they are. But 2 more. I have, if I'm adding up I squared as I goes from 1 to n, I get n times n plus 1 times 2n plus 1 over 6. If I'm adding up I cubed, I'll have n squared times n plus 1 squared all over 2. So let's go back to that oogie example with the squares. I can break this up. I goes from 1 to 15. Of all this crap, I can break it up to the I squares, 2 times I minus 5 times the summation of the ones. Using my formulas, I know that this one gives me n times n plus 1 times 2n plus 1 over 6, where n is 15. So I'll get 15 times 16 times 31 over 6. Here I have my formula of n times n plus 1 over 2. So I have 15 times 16 over 2, and I had a 2 on the outside, which goes here. Last one, if I add I from 1 to 15 of 1, that's just going to be 15 again. So I have minus 5 times 15. And again, you crank it out and you get 1405. So remember, we've got these 6 formulas. Put them somewhere so you can refer to them and use them as you're doing your homework.